Hi everyone, this is Mr. Cervone. Welcome to my channel. In today's Do Now, we have a box of Uncle Ben's rice modeled as a rectangular prism with dimensions of 6 inches by 4 inches by 2 inches. The Mars company has decided to redesign the box so that it has the same volume as the old one, but the base is to become a square 4-inch on the side. How tall is the new box? And what is the total surface area of the new box? Okay, so for number one, first we want to calculate the original volume of the box, which is just 6 times 4 times 2, and you end up with 48 inches cubed. For the next step, we want to calculate the following. So for the second volume, we know that it's going to be the same, or 48 inches cubed. Which is equal to the square 4 by 4 inches times the height. The height is the unknown, and that's what we're trying to find. How tall is the box? So if you do the math, you end up with 48 equal to 16 times h. Therefore, h is 48 over 16, and the new height, the height of the new box is going to be 3 inches. So for the second part, all we need to do is find the individual surface area and add them all up. So in this case, we have 4 times 4 by 3, which accounts for the sides and the height. And then we have 2 times 4 by 4, the two sides in the front and the back, which is going to give us a total surface area of 80 inches squared. Okay, so in my previous video, we learned about prisms. Today, I would like to introduce pyramids. And how do we find the lateral area, surface area, and volumes of these pyramids? But before getting into that, let's first define pyramids and let's discuss what the properties of pyramids are. Okay, so here's the definition of pyramids. A pyramid is a polyhedron formed by connecting a polygonal base and a point called the apex. Each base edge and apex form a triangle. So as you can see here, the base in this particular case is a square polygon. Obviously, the base could be any other shape or any other polygon, for example, a pentagon or even a triangle or a hexagon. And the lateral surfaces are composed of triangles, and they all meet at the apex. Okay, so now that we have defined pyramid, let's discuss the properties. So first of all, a pyramid is named after its base. So it's very similar to what we have learned with prisms. For example, if you look at the first one, the first pyramid is called a pentagonal pyramid. However, we want to add a few more details since we know that this pentagon or the base is a regular pentagon. Maybe we can add the word a regular pentagonal prism. Also, look at the difference between the first and the second pyramid here. We know that the axis of symmetry is perpendicular to the base. So we want to also add that it's a right pyramid. So for example, for the first one, so let's call this A. So for part A, that is called a regular right pentagonal pyramid. Now, how would you call the second pyramid? So let me call that one B. Well, we learned with prisms that if the shape is tilted, then we have the word oblique. We know that the base is a regular hexagon, so you would call that a regular oblique hexagonal pyramid. Then figure C, we can call it a regular right square pyramid. And for D, that is a regular right triangular pyramid or a tetrahedron. Notice that on the bottom, we have 3 figures or solids that are not considered pyramids. Obviously, this one is not a pyramid because the base is not a polygon, but it's simply a circle or a rounded shape. This is also not considered a pyramid because there's no apex. This is also not considered a pyramid because the lateral faces are not triangular. Okay, so let's look at the pyramid a little bit more into detail. Okay, so here we have a pyramid. Usually the altitude is defined as the perpendicular distance from the base to the apex. Notice that the altitude intersects the polygon at its midpoint or at the center. Here we're talking about a right pyramid. If it's oblique, then it's not going to be at the center again, but it will still be perpendicular to the base. Then we have L, which is the altitude of one of the triangular faces, and we actually need the slant height and the altitude to define the lateral area, surface area, and volume of the pyramid. Okay, so how would we be able to find the lateral area? Notice that the lateral area is the surface area without the area of the base. So basically just the surface area of the triangular sides. Well, let's imagine we unfold the pyramid and would only see the triangular faces. It will look something like this. Okay, so in this particular case, we have 4 triangles. And when we have 4 triangles, we know that to find the area of those, it's just 1/2 times the perimeter times the slant height. And that is the formula for the lateral area. Okay, so how do we obtain 1/2 times perimeter times the lateral or the slant height? Well, let's think of it as follows. Let's say you want to find the area of one of the triangles only over here, okay? We know we can actually call the sides here S, okay? So that means that in the triangle, this is S, okay? And the height of this particular triangle is the slant height L. So that means that the area of one triangle is equal to 1/2 times the base, in this case it's S, times the height, which is L, which is the slant height, okay? Okay, so now if you want to find the lateral area, which includes the area of all the triangles, all you need to do is multiply that by 4. So 4 times 1/2 times S times the slant height, okay? So let's generalize this though. The 1/2 always stays the same. Where did this 4 come from? Well, 4 is actually N, where N represents, let me write this on the side, N represent number of sides of the polygonal base. Okay, so that means that in this case, the lateral area is equal to 1/2 times N times S and times L. Okay, so let's think about this. N times S, what is that equal to? The number of sides of the polygonal base times the length of each side. Well, that is equal to the perimeter. Perimeter P. Therefore, the lateral area is just equal to 1/2 times perimeter times slant height, okay? So that is the formula to find the lateral area. Okay, what about the surface area? Okay, so the surface area is equal to the lateral area plus the area of the base. So it's just simply that formula. And we also know that the area of the base, since it's a polygon, we learned that already, that is equal to 1/2 times the apothem times the perimeter, okay? So as you remember, if you have, for example, a pentagonal base like this, notice that it's not drawn to scale, okay? The apothem is defined as the distance from the center of the pentagonal base, or in this case, any polygon, to the midpoint to one of the sides, which is perpendicular. So that is A, okay? So if you know the apothem and you know the perimeter, you take the product and divide it by 2, and that gives you the area of the base, okay? It's actually very simple to find it for square bases or triangular bases, but in other cases, you might want to use trigonometric functions as well. Okay, now let's go to volumes. Okay, so there's no easy way to derive the formula for the volume, but you can remember that the volume is just base times height, or the area of the base times the height divided by 3. I will post a YouTube video in the comment as a link, so you can watch it and see how the volume is being derived. Okay, so that's it for today's lesson. The most important thing is for you to remember in today's lesson how these properties of the pyramids, what they are, and how these are named. But also, please remember the formulas, okay? The lateral area here. So that's very important to remember the lateral area here. 1/2 times perimeter times the slant height. Then the surface area, which is just the lateral area plus the area of the base. And finally, the volume, which is 1/3 times area of the volume times height. So at this point, you can now go ahead and do homework 96. You can find that on Schoology. This homework assignment is due Wednesday, April 8th. Other than that, I wish you a great day, and please email me if you have any questions.